So the last part of our discussion on epilepsy is to look at the different types of epilepsy. So we're combining the two things we did. We defined the type of epilepsy, and then we thought about, okay, here are some drugs that can be used to treat epilepsy. So what we're going to do is we're going to combine those, and we're going to think about what type of drugs to best use to specifically treat certain types of epilepsy. And we are mainly going from the actual recommendations of doctors who treat epilepsy. So here we'll see a link to a website that tells you how to prescribe for treating epilepsy. There is another option if you prefer a PDF version of that information as well. So in this you can see all the warning updates for valproate and topiramate. Because they're doing multiple things, they can cause more severe problems during pregnancy. And there's an update for use in men and how it can, it seems to be how it can affect sperm development as well. But in this one, topiramate should not be used in pregnancy. Valproate must not be used in women and girls of childbearing potential. So they often update these things. These are the most recent updates. And so if you want to investigate further, there's a whole bunch of information in here if you want to look into any of that in more detail. I'm going to give you the summary of it. And so the things that you're going to see here, you're going to add to where we define these in the Objective 1. So you'll notice that Objective 3 in your handout only has a little bit, but you're really adding these in that table in Objective 1. Now, one thing to mention, you're going to want to write this down. Valproate must not be used in women and girls of childbearing potential unless there's nothing else that will work. And if it is being used, you have to make sure that a contraception program is in place so that these individuals should not have children. And so when we talk about the partial seizures, the treatment for both simple and complex is the same. So lamotrigine, it is best because it's most specific. So it does more specific things to the voltage-gated calcium and voltage-gated sodium channels. So lamotrigine is the first line, so the thing that you would try first for these. Carbamazepine to males and females. However, for females, no possibility of pregnancy. Same thing for the valproate. And then, if neither of those are going to work, then second line is levetiracetam or oxcarbazepam or valproate, again, not to females, basically. So you have three main ones that are going to be, for these ones, more specific and more effective. So as the partial seizures are both treated in the same manner, the generalized seizures are pretty much all different. The first three are going to be a little bit easier to treat. And when we get to the last ones, you'll notice that there's really not a lot of good options for everybody. But for these generalized absence, one that we haven't actually talked about yet, it was not in that original list, but ethosuximide is going to block a specific voltage-gated calcium channel. And then again, valproate to males only. And then the second line, lamotrigine. So thinking about, again, specifically in binding and inhibiting voltage-gated sodium channels and voltage-gated calcium channels for these ones. The generalized myoclonic, first line, levetiracetam, and then if that doesn't work, valproate to males again. And just remember, the levetiracetam is the one that is specific and prevents the neurotransmitter release. And then, for generalized clonic, no one actually knows. It's kind of a crapshoot, so it's, well, let's try this one. Nope, that didn't work. Let's try another one. No one knows what will work best for that. Okay. Then when we get to the other generalized ones, you see that these are kind of harder to treat, and you kind of need something that is going to work to inhibit more things or to affect more things. So remember, the valproate is going to affect all four, the voltage-gated sodium channels, the voltage-gated calcium channels, the glutamate receptors, so inhibiting all three of those, and then increasing GABA activity. So when you have a generalized seizure, it all happens at once in multiple areas of the brain, and in order to prevent that, you want something happening at all four areas of those. But because it doesn't, or because there can be birth defects because of it, it's not good recommendation for females, and so there's really no good treatment for the generalized tonic or the generalized atonic for females. So they have to go by with something like lamotrigine, but it's not going to be the best. So for the generalized tonic, sodium valproate is really one of the only ones. No good recommendation for females. For the generalized tonic clonic, or that grand mal, lamotrigine seems to work a little bit better. But if that doesn't work, then sodium valproate is your backup, but again, not great for females. But you can consider some of the other ones, carbamazepine, oxcarbazepine, but sometimes that can make the myoclonic or absence seizures worse, depending on the mechanism of action for the particular seizure. And then, just like this one up here, copy and paste that first line, sodium valproate, but no good recommendation for females, so they give other things until they figure out something that might work for those females. And again, to highlight, valproate not used in women and girls of childbearing potential unless nothing else works. And then, if you notice, we had a whole list of all those other things that are anti-epileptic drugs, but the first line for all of them, it's lamotripine. Oh, no, not lamotripine, but lamotrigine. Levetiracetam was relatively common. Ethosuximide's a new one. And then we've had these two before, but then the valproate is for everything else. And so those other drugs aren't often like the only thing that someone will use. So drugs listed in the other table are often used as adjunctive therapies, or basically add-on therapies. So using more than one anti-epileptic drug to prevent the seizures. So it's usually a drug cocktail. And if we think about side effects, that's not necessarily fun for people who have epilepsy. And one of the ideas is that in order to really control them, you have to have, an individual has to be on multiple drugs at the same time. And then what I want to talk about for in class is looking at the genetics of individuals who have epilepsy, and then making more specific treatments for that. So we'll look at this particular paper during class, and what you'll see when a genome-wide association study, so for those of you who have had genetics, this might look familiar. For those of you who haven't, it's okay. I'll explain it to you. But basically, you compare people who have epilepsy to people who don't have epilepsy, and you see what genes might be leading to that epilepsy. And in this one, what you'll see, anything that's above the line is a possible candidate or a possible target for genetic differences that are going to lead to epilepsy. And I hope what you can see from this is that it's not just one thing. An individual's epilepsy might be caused by a mutation in this gene. An individual's experience of epilepsy might be caused by a mutation in this gene, or a mutation in this gene, or a mutation in this gene. So what we are doing in our treatments is just targeting the symptoms, which is overactivity of the neurons, but each individual's cause of epilepsy might be something different. So one of the most common one is this CACNA2, basically voltage-gated calcium channel. This SCN is voltage-gated calcium channel. This SCN is voltage-gated calcium channel, and these things are other different things. So the genetic cause for epilepsy is not just one thing. And so when we go to treat, do we have other things that we can think about as opposed to the treatments that we already have in place, which we know may or may not work for specific individuals and may have side effects that are going to be pretty severe. And within the same paper, what they did was they took that information from the genome-wide association study and now are using it to see if they can repurpose drugs to use them for the treatment of epilepsy as well. And when they did that, there were 20 drugs licensed for conditions that they now think and are going to try for treating epilepsy. And to finish for this one, I just wanted to highlight some non-pharmacological treatments for epilepsy that I find interesting. So a ketogenic diet. We don't know exactly how it works, but it might be preventing oxidative stress. It might be increasing the release of GABA. It might be changes in the mitochondria. Might be many different things. We don't know exactly how it works, but sometimes it works for drug-resistant epilepsy. Another thing is surgery. So doing a cutting the corpus callosum to prevent the transmission of the electrical activity across the brain. And then also you can sometimes go in and take out small sections of the brain, which doesn't sound like a good idea, but can prevent epilepsy or can prevent the seizures. And a final non-pharmacological is stimulating the vagus nerve. So you can look at any of these kind of alternative treatments, but I wanted to focus mainly on pharmacological, and we will continue our discussion during class.